Okay, so let's come back and take a little bit closer look at some of these factors that influence brain functioning, the time of awakening, excuse me, the circadian rhythm, which we're going to take a look at in great detail probably next week. It is more than just a sleep-wake cycle. I mean, it's a part of it, clearly, okay? But it's the stuff you see on the slide. There are very predictable changes in body temperature that occur during particular times of the day. And very importantly, and all this we're going to come back to and looking at from a clinical perspective a little bit later on, but at nighttime, it's necessary for people's core body temperature to cool off in order to get into slow wave, or also referred to as deep sleep. And there can be problems when people don't do that. Hormone secretion. The hormone cortisol, when people will go to sleep at night, unless they have depression or other kinds of physiological problems with cortisol, normal functioning people, the level of cortisol is 0 and stays that way until about an hour and a half before you wake up. And that's a good thing because cortisol completely destroys slow wave sleep. So it's good that it's not there during most of the night. Okay. During the night slow wave sleep, that's when most of growth hormone is released. So there's very predictable diurnal variations in the release of certain hormones. The regulation of the immune system. Just one example of this. I mean, my mom was right when she said, I got sick, go sleep. It really makes a difference. And actually sleep does help to sort of fortify the immune system. In a study done many years ago, they took young, healthy adults and they put them in a sleep lab, and then they went to sleep. And the sleep researchers are really good at doing this. When they would start to get into deep sleep, they would jostle them a little bit. And they most of the time it didn't wake them up, but it knocked them out of slow wave or deep sleep. And so you can experimentally completely deprive a person of deep sleep for a night. And what they found the next day, on average, the percentage of natural killer cells, which are an important sort of first line defense in the immune system, dropped on average in this group of people by 28%. So there's something about slow wave sleep that helps to help the immune system. Sleep-wake cycles and brain functioning. Okay, critical factor is the first dose of light, and that is the thing that stabilizes the circadian rhythm. And we'll look at some treatment strategies later that really focus on that. But let me just say something right now before we go on, and that is, people move away from the equator. Hardly anybody wakes up at the same time each day, every single day, weekends and holidays and stuff like that. People are doing things that potentially could really throw a wrench in the circadian rhythm. But what happens is that human beings are enormously resilient. So there are people that, for instance, they have different times they wake up. There are people that work the night shift. They have hardly any bright light exposure. There are people that are very sedentary, and yet they continue to function. Now, there's a smaller percentage of people that these factors can really destabilize it and play a critical role in psychiatric disorders, okay? And these are issues that need to be addressed treatment-wise. For most of us, if the circadian rhythm is off, probably the most common example of the kind of event that would cause this would be jet lag. And I know if I spend 3 or 4 days on the East Coast and come back for 3 or 4 days, I'm waking up at 3 in the morning, and I'm tired, I can't really think very well during the day, but I get back on my feet. But some people, and most notoriously are people who have bipolar disorder, they can have that same amount of exposure outside their time zone and come back, and that can flip them into a psychotic manic episode. So it's a big deal for people that are vulnerable. Okay. There's a term called entrainment. And entrainment is where there's a external physical stimulus that regulates an internal biological process. Let me say that again. An external stimulus that regulates biological functioning in the organism, in this case in human beings. And when you're looking at stabilization of the circadian rhythm, then it's the first dose of light is the most potent in terms of entraining the circadian rhythm and maintaining what they call circadian rhythmicity. And again, we'll come back with specific treatment strategies later on. This could be a big deal for a lot of people who have mood disorders. Okay. Light, sleep, and exercise. People talk about seasonal affective disorder, and you better believe it. I mean, it's for real. I just got back from Alaska, and every time I go up there, I hear these horror stories, and the statistics confirm this. 3 times the rate of suicides, 3 times the rate of major depression, 3 times the rate of domestic violence and alcoholism. The farther north you get, it's not just in Alaska, it's all around the world. And this is seasonal affective stuff. You know, that prolonged periods of no light exposure, it can really affect people that are vulnerable, especially to mood disorders, okay? But think about this. It's not just seasonal stuff. In fact, that actually is a pretty small factor. The vast majority of human history, people lived outdoors. And now everybody lives indoors. And it's estimated that people in the United States, adults in the United States, are outside less than 10% of their day. Obviously, it varies from person to person, but on average. And most of the time when we go outside, we put on sunglasses. And so it's just that choice. I happen to like sleeping indoors, okay? But it's that choice that really is mostly responsible for decreased bright light exposure, not just seasonal. Also, 20% of adults in the workforce are chronically working on the graveyard shift, night shift, okay? And so their life, you know, over months and years of working in that kind of profession, they are chronically deprived of bright light exposure. So it's not just seasonal affective disorder. There are a number of different factors that can cause decreased, they call it photic stimulation, and can lead to mood problems in particular. Here's another factor too, and this is, again, is just pure conjecture. But if you had a group of 20 or 30 of these primitive early humans trying to eke out a living, you know, in the Serengeti, every person had to do their work to contribute to that. And we already talked about that, but the point I want to make here is, I mean, nobody knows that people back then, you know, got major depression. I mean, who knows? Most people didn't live beyond the age of 20. But if somebody did get depression, there's probably no way that that person could withdraw. And a huge issue with depression is a massive withdrawal from life. People, you know, stay indoors. They don't go out to eat dinner like they normally do. They don't go to church. They don't return phone calls. This massive pulling away from connection with the things in life that really make life worth living. And there's some really convincing research to show that if you force people to stay engaged with their life, it can significantly reduce depression. Peter Lewinson did the pioneering work in that. The point that I'm making, though, is because they needed every person to do their job each day to gather food, it's very unlikely if somebody developed depression that they could have the opportunity to kind of steal away, you know, and hide out and that kind of stuff, because the community would need them. So anyway, again, just a theory.